Hi everyone, this is Mrs. GA and today we're going to be graphing cosine. Alright, I have a quick warm up for you guys, so if you could pause the video and give it a try, we can check your answers in just a few seconds. Okay, so go ahead and check your answers here. So first I want to point out the values that I picked in the t-chart, the x values. I picked them strategically to give us quote-unquote nice values. So notice I picked like pi over 3 instead of pi over 6. So we were working with 1/2 instead of root 3 over 2. But again, you know, it's up to you how you would graph something like this, but I'd say pick your values strategically. So you can see that with this cosine graph, we still have that kind of wave shape, the same shape that we had with our sine graph, but you'll see that it looks a little bit different, and that's because it's essentially been shifted over by pi over 2 units. So instead of starting at the origin, like sine does, and then going up from there, we're actually starting at the maximum and then going down to the bottom and then back to the middle and then back to the top. But you can see that our graph still completes that full cycle over the distance of 2 pi units. So this is the parent function for cosine. Of course, it would continue this pattern infinitely to the right and left, but this is just one cycle of our graph. All right, so this might seem a little bit repetitive. We covered this in the sine video, but I just want to review it because it's so important. So we are going to be, of course, talking about that concept of what a period is, which is the horizontal distance of one full cycle of our function. Amplitude, which is the vertical distance from the midline up to the maximum or from the midline to the minimum. So just remember, the total distance from the very top to the very bottom would actually be double the amplitude. And note, our amplitude should always be positive. And then last is this term phase shift. Just remember, a phase shift is just a horizontal translation, but when we're doing trigonometric functions, we just use the term phase shift. Okay, so here's another picture of our cosine parent function, so we could talk a little bit more about some of the characteristics in more detail. So first, that idea of period, again, just like sine, it does take 2 pi units to complete a cycle. So notice going from a maximum back to the maximum is 2 pi. So the amplitude for our parent function is still 1, because you can see the midline is our x-axis, so the distance from the midline to the maximum or to the minimum is just 1. Our domain is always going to be all real numbers for these, and our range is between and including -1 and +1. So of course we're going to be graphing with transformations today. So we could see that negative out front, which would cause a reflection over the x-axis. This a value, in terms of our trigonometric terminology, would, well, since it's a vertical stretch, our y values would be stretching or shrinking. So that would affect the amplitude. So the amplitude is essentially going to be whatever the a value is. So just remember that our amplitude, or that a value, is always positive. If there's a negative out front, that's just a different transformation. So the b value, you see right here, that's when we have our horizontal stretch or shrink by a factor of 1 over b. Since it's a horizontal stretch or shrink, it's going to be multiplying our x values, so our x values are going to be stretched or shrunk. So that would actually affect the period. It would affect the horizontal distance of our graph. So there's a formula to find the period. It's just 2 pi over b, but really what we're doing is we're taking the initial period, which is 2 pi, and we're multiplying it by the stretch or shrink factor, which is always, remember, 1 over b. Okay, so you could always find the period by, again, taking the parent function period and multiplying it by the reciprocal of your stretch or shrink factor, which is that b value. So h we know is a horizontal translation, a shift left or right, so that's going to make a phase shift. And the k is a vertical translation, so a shift up or down. So that's going to shift the midline of our graph. All right, so now we're going to try actually graphing some of these with transformations. Okay, so the first method we're going to do for graphing is we're going to actually use a table of values. So we're going to take some key points from our parent function, which in this case is just cosine of x. And then we're going to transform the coordinates according to what I see in the function f of x. All right, so I'll take some values from the warm-up that we did. So I would take 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. Those are 5 great coordinates to start with. Of course, you could always include more and you'll have a slightly more accurate graph, but I think this will provide plenty of accuracy for us. So let's start with any horizontal changes we see. Here I see that we have a horizontal shrink by a factor of 1 over 4. So that means all of my x values will be multiplied by 1 over 4. And I see here that we have a vertical shrink by a factor of 1/2. So all of my y values will be multiplied by 1/2. So when I do this, let's change our x values first, and then this becomes pi over 8, pi over 4, 3 pi over 8, and then pi over 2. And then our y values become 1/2, 0, negative 1/2, 0, and 1/2. So we do need to think about the scale of our x-axis. So if you look at your x values, you can see that really they're just increasing by pi over 8. So I think pi over 8 would be a great way to scale our x-axis. And then maybe for the y-axis, I don't know, let's rescale it. So this first tick mark is positive 1/2. You don't have to do that. You can estimate where that is, but you can scale your x and y-axis however you want. So if you have 0, 1/2, pi over 8, 0, pi over 4, negative 1/2, 3 pi over 8, 0, and pi over 2, 1/2, you can see that that's one full period of our cosine graph. So I'll still kind of continue it, like I'll curve around at the end and add my arrow. But we need another period, so I'll kind of continue that pattern going to the left. So I'll go middle, down, middle, top. And again, at the end, just make sure you kind of curve your graph around, because I'm not just going to keep going up straight, right? It does hit that maximum value at 1/2. So if we look at the graph, we can see that the period of our graph this time has changed. Now it's starting at 0, and then you complete a full cycle by pi over 2. So our period is pi over 2. Now, of course, we could find that by taking the original period of our parent function and multiplying it by our shrink factor of 1/4, which gives us pi over 2. But we also see it in our graph. The amplitude we can see is 1/2. That's the distance from the midline to the maximum or minimum, but we see that it's also that a value right here. Our domain is going to be all real numbers, and our range is from negative 1/2 to positive 1/2. So again, this is just one strategy you can use to help you graph our cosine function. All right, so give this strategy a try on your own. Please pause the video, and you could check your answers when you're ready. All right, so go ahead and check your work here. So this one, you can see, since I don't have any scale on my x or y axis, I'm actually just scaling it by 1. So kind of a unique problem where you can see our x values are just increasing by 1. So here we do have a horizontal shrink by a factor of 2 over pi. And we have a vertical reflection, so over the x-axis. So you can see here we're starting at the minimum instead of the maximum. And you can see that our period is 4. Again, I can see that in a graph, but I could also take my original period of 2 pi and multiply it by our stretch or shrink factor, which is 2 over pi. So we get 4. And then make sure you check your amplitude, domain, and range as well. All right, so using a table of values is a great way to graph, but it's also really important that you can kind of look at an equation and just kind of visualize like what your graph should look like, determine what the period of your graph is in a different way rather than using a table. So a different way we're going to practice graphing is using what I just call logic. So there's kind of this process I go through when I'm graphing cosine. I really like to start by sketching out the midline of my graph. So I kind of do that with a dashed line. This is just a guideline for me. It's not actually part of the graph, it's just a guideline. Then I use the amplitude to help me determine my maximum or minimum values, and I actually create dashed lines there so I have a guideline of where my graph stops and turns around. Then I use the period of the graph to help me scale my x-axis. Typically, if you take your period and you divide it by 4, that's a really good way to scale your axis, because if you think about it, you know, a unit circle has 4 quadrants. That's why it takes those 4 quadrants to complete its cycle. So if you split up your period into 4, it's typically a nice way to just be able to jump from the maximum to the middle to the minimum to the middle and back to the maximum. Now this works about 90% of the time. Sometimes if you have a shift left or right that doesn't quite match up in terms of the units with your period, you may have to do a little adjusting. But typically I take the period and I divide it by 4. And then I just determine my starting point. So for cosine, I always say cosine starts at the maximum, right? For the parent function, we can say it quote unquote starts at 0, 1. Now, of course, there's no real starting point or end point because it's continuing infinitely to the right and left, but that's how I like to think about it, and it gives me a starting point for graphing. So let's kind of give this process a try. So if you look at this first function, you see we have a couple of transformations going on here. So first I notice that our graph is shifted down 2. So that means that the midline of our graph is going to be at -2. So I like to draw on just a little horizontal line here at y equals -2. And then I look at the amplitude of our graph, and I see that the amplitude is 1. That a value is just 1. Remember, the negative is a different transformation. So that means from the midline, if I go up 1, that's going to be my maximum value, so at y equals -1. And if I go down 1, that's going to be my minimum value, so at y equals -3. And then I can look at our graph and look for a b value to determine the period. So here I don't see any horizontal stretch or shrink, which means that my period is going to be the period of our parent function, which is 2 pi. So if you take 2 pi and we split it into 4 parts, we get pi over 2. So I think that's going to be a good way to scale our x-axis. In this case, we have pi over 2 pi, 3 pi over 2, 2 pi. So now I need to look for that starting point, and when I'm doing that, I have to take into account 2 things. I have to take into account this reflection, which means instead of starting at the top, I'm actually going to start at the bottom. And then I also need to take into account this phase shift. So this is actually shifting to the left pi units. Okay, so typically, remember with the reflection, I would be starting here. But now my starting point needs to be to the left pi unit, which is 2 tick marks on our x-axis. So our quote-unquote starting point is right here. I'll do the starting point in red, just so you can follow along. So here's the starting point I'm using. Again, the reflection brings our starting point to the minimum, and then we have to shift to the left pi units. Okay, from here, we can simply follow the pattern of cosine for hitting our 4 quadrants. We would go middle, maximum, middle, minimum. So that's 1 full period to the right. And if we need 2 full periods, I could continue that pattern to the right again, or I could continue the pattern to the left. I can go middle, maximum, middle. I could add a little extra tick mark here, and then minimum. And of course, we could have also continued that pattern to the right. So you need to have at least 2 full periods here, and make sure you kind of curve your graph around at the end to show that it is turning around. So for our domain, of course, it's going to be all real numbers. There are no domain restrictions for sine and cosine, so it's always going to be all real numbers. And we can see that our range is from -3 to -1. All right, let's try another one. For this one, I see that our graph has shifted up 1, so our midline is going to be at +1. And I see that our amplitude is 2, so that means the distance to the maximum is going to be 2. So the maximum is going to be at y equals 3. And then I subtract 2 to find my minimum value. So it's at y equals -1. So now I need to look at the period of our graph. So I see here that we have, we're going to have a horizontal shrink by a factor of 3 over pi. So we take our original period, which is 2 pi, and we're going to multiply it by that reciprocal factor, which is 3 over pi, and then we see that our period is actually 6. So our period is 6. So in this case, I'm going to take that, split it into 4. So 6 over 4 is 3 over 2. So I think we can scale our x-axis by 3 over 2, and that should work pretty well. Put it right underneath here. So that means this is 3 over 2, this is 3, this is 9 pi over 2, and this is 6. Okay, so we're just counting by 3 over 2. And now let's talk about our starting point. So we know that cosine starts at the maximum, so it would start here. I don't see any reflection, so it's going to stay at the maximum. I don't see any shifts to the left or right, so it will start right here on the y-axis at the maximum. So my starting point is right here, and then I'm just going to go middle, minimum, middle, maximum. And since we've scaled our x-axis appropriately, it allows us to just hit those 4 quadrants. Because if you want to follow this pattern of just going middle, minimum, middle, maximum, you have to make sure your full period is split evenly into 4 parts. So that's why I take the period and I split it into those 4 parts. And then we can continue that pattern going backwards to the left. And there you go. Here's our second full period. Okay, and again, make sure your graph kind of curves around at the top with that arrow to show that it's continuing infinitely. Our domain is all real numbers, and in this case, our range is -1 to 3. All right, so go ahead and pause the video and see if you can try this one on your own. All right, go ahead and check your work here. So you can see that this shift down 2 is shifted my midline to -2. And since my amplitude is 1/4, that means my maximum is at -7/4 and my minimum is at -9/4. Here I see that there is a horizontal stretch by a factor of 2. So our period is stretched from 2 pi to 4 pi. So you can see I scaled my x-axis by pi units. And then cosine starts at the top, and then I just hit my 4 quadrants to complete each period. All right, so now we're going to try one that's a little bit trickier. So here you can see that we have a horizontal shrink and a horizontal shift. So remember, anytime you see both, we absolutely need to make sure that this b value is factored out. So the first thing I need to do here is factor out pi. So we have negative cosine times pi times x minus 1/2, because I'm dividing by pi here. So you can see if you look at this, your original equation, you might say, oh, my graph is shifting to the right by pi over 2, but our graph is actually only shifting to the right by 1/2. So you really, really need to make sure that you remember to factor out that b value before you do anything else. Okay, so from here, I don't see any vertical shifts, so I see that my midline will just be at the x-axis, and my amplitude is just 1, so I'm going to go up 1 and down 1. Now let's talk about the period. Again, I have a horizontal shrink by a factor of 1 over pi. So take your original period, multiply it by that reciprocal of the factor, and we get a period of 2. So the period is 2. So if I split the period up into 4 parts, I'd be counting by 1/4. And I think that will be a good way for us to scale our x-axis. So now we need to talk about our starting place. So again, cosine usually starts at the maximum. We do see a reflection, so that would bring us down to the minimum. And then we also saw, again, that shift. that phase shift, and this is going to go to the right by half a unit. So I'm already at the minimum because of the reflection, and then I need to shift my starting point to the right by half a unit, so that's 2 tick marks. So this is now my starting point. But then once I have the starting point, the rest is easy because we did all the setup. We have our boundaries, our x-axis is scaled strategically, so the rest is just hitting our 4 quadrants. 1, 2, 3, 4. And I added a little tick mark on the right. So there's 1 full period, and we could go another period to the left, just like this. And there you go. So we can see, of course, our domain is all real numbers, and our range is from -1 to +1. So again, just be really careful when you see a b value and an h value. The b value must be factored out before you assess what type of transformations are happening. All right, let's try one more of these together. So same thing, we need to factor out that b value. So I'm going to rewrite my function. So we have 2 times the cosine of 2 times x plus pi over 8 plus 1. Okay, so I see that our graph is shifted up 1. And I see that our amplitude is 2, so my maximum will be here at 3, and my minimum will be here at -1. Then if I'm trying to find my period, again, I have a horizontal shrink by a factor of 1/2. So you take 2 pi, multiply it by 1/2, and it is pi. So our period is now pi. So notice the period is half as long because, again, it's a horizontal shrink. And then to scale my x-axis, I can try taking that and dividing it by 2. So we would get dividing it by 4. So maybe we'll scale by pi over 4. And now we need to talk about our starting point. So again, cosine starts at the top, so we would start here, but we do see a shift. So this is going to shift our graph to the left by pi over 8. So instead of starting here, I need to just shift it to the left pi over 8, which is going to be just half a tick mark, right? So it's going to be right here, because remember, we decided to scale our x-axis as pi over 4. So then from here, we're just going to hit our 4 quadrants. Just be careful, instead of going like a full tick mark, you're still going like a full tick mark, but you have to estimate halfway in between. So we'd go 1, 2, 3, 4. And then we could go 1, 2, 3, 4. So here we have 2 full periods of our graph. Alternatively, instead of, kind of estimating where this is, we also could have, of course, rescaled our x-axis. So instead of counting by pi over 4s, we could have counted by pi over 8, so that's totally fine as well. So here our domain is going to be -infinity to infinity, and our range we can see is -1 to 3. Okay, I have one last problem for you to try on your own, so please pause the video and give it a shot. All right, so here you can see we do need to factor out that 4. So this is actually a shift to the right by pi over 4, not to the right pi. Our midline is at 2. Because of our amplitude, our maximum is at 5 halves and our minimum is at 3 halves. The period, due to the horizontal shrink by a factor of 1/4, is now pi over 2. So you can see I scaled my axis and my x-axis by pi over 8. And then to find the starting point, cosine starts at the maximum, the reflection brings it to the bottom, and then I have to shift to the right pi over 2. And so the red dot is our starting point. And then I just hit my 4 quadrants, again, because we did the work in advance to scale our x-axis appropriately. Makes it really easy to graph the rest. Okay, so that is all for today's video. Thank you so much for watching.